Alright, so in this video we're going to go over section 2 of exam number 1 in relation to continuity and limits. So right here we have the graph of y equals f of x, and we have all these different limits. And we're being asked, is f being continuous at x equals 5? So x equals 5, we have 2 points right here. So we have limit x equals 5 from the right side, which of f of x, which equals negative 0.25 roughly, and it roughly equals about negative quarter. And then from the left side you have limit x approaching 5 from the left, f of x, which just gives you 2 in this case. So gives you 2 in this case. So given that they have different values at x equals 5, we can say that the f is not continuous at x equals 5 because they have 2 different values in terms of f of x when it comes to the limits approaching the x value. So we can just write this as limit x as approaches 5 f of x is dne, because limit of x approaching to 5 from the right side does not equal limit of x approaching 5 from the left side, f of x. So the type of discontinuity that would occur right here, you'd have a non-removable jump. So non-removable jump right here. Just write that down real quick. And the reason why we'd have a non-removable jump is because we have sort of a piecewise function going on over here. So we'd have a gap between the 2 points approaching the same x value at x equals 5. So in that case, because there's a gap in between them, it's going to be a non-removable jump in that sense. And now looking at is f continuous at x equals 9. So x equals 9, in this case we'd have a vertical asymptote at x equals 9. And because we have vertical asymptote, we have the limits approaching infinity. So in this case it's to limit x approaches to 9 from the positive side, f of x, which equals positive infinity. And then we have limit x approaches 9 from the left side, f of x, which just equals negative infinity. And because these two hand limits have different f of x values, that means that limit of x to the 9, limit of x, as x approaches 9 f of x, is just also dne, because limit x approaching to 9 from the positive side, f of x, does not equal limit x approaching to 9 from the negative side, f of x. And so because of the discontinuity in this case, we'd have a non-removable infinite for the discontinuity, non-removable infinite, because the 2 hands over here, when approaching x equals 9, they approach opposite infinites. The right hand side approaches positive infinity, whereas the left hand side approaches negative infinity. So because they have opposite values in that sense, they would just this would just become a non-removable infinite in terms of the type of discontinuity. So yeah, this is how you solve these types of problems. So thank you.